Hello and welcome to another video. We're going to be continuing on with the Typescript line 75 and we're going to be working on rotate image next. So in this picture, or in this problem, you're given an n by n matrix representing an image and you want to rotate it by 90 degrees clockwise. So you can see like this rotated 90 degrees would be this. And we need to figure out how to do that. And there are a few ways to do it, but we're going to try to do like the elegant solution, quote unquote. So essentially, yeah, this is rotated 90 degrees, and this is also rotated 90 degrees. We're going to focus on this example. We could do either one, technically. Yeah, I guess maybe we'll focus on the second one, just because it's a little bit, yeah, it's a little bit bigger. Let's get rid of this. And let's actually look at this. So let's draw this matrix out, and let's draw out the numbers, and let's just show what we need to actually do. So as always, I'm going to have the worst lines ever, but okay. All right. And we are going to actually index these to make it easier for us in the future. So let's do that. So let's index these. And let's just say this is 0, 1, 2, 3. 0, 1, 2, 3. Okay, and then we can write out our numbers in here. So 5, it's a little small. Actually, I just write them in. So 5, 1, 9, 11, 2, 4, 8, 10, 13, 3, 6, 7, 15, 14, 12, and 16. And essentially, we need to do two things to do this the way I'm going to propose. We are essentially going to invert this. So if you think about it, let's say we draw a line right here, and we're actually going to invert it around this axis over here, kind of thing. So think about, like, if you're holding this piece of paper, you have one finger or one hand here, and you flip it over, holding that. Think of what that would look like. And that's essentially what we're doing. So what would happen is, like, 15 and 11 would switch, and then so on, right? So you are essentially inverting, like you want this part to be over here, and this part is going to be over here. You're inverting it around that left diagonal. And we need to figure out to do that for this first part. The second part's going to be a little bit easier. This one's hard to visualize. What actually gets swapped, right? So if you invert it completely, what gets swapped? Well, this left diagonal is going to stay the same, right? If you flip this piece of paper over, essentially, this is going to be the exact same. Like if this was a piece of paper and you would invert it, this would be the same. So we don't need to worry about that. But then what things swap? Well, if you think about it, these two swap, right? And then what else swaps? So if you can picture it, I know it's not super easy, but like what things actually swap? So those two swap, these two swap, and then what else? This 15 and 11 swap, right? So 15 and 11 will swap. But essentially, let's look at some of these. Let's look at some of these things that swap, and let's figure out like what's the correlation here. So this 15 and 11, this is row 3, column 0, and this is row 0, column 3. So you kind of see like the row and the column basically got swapped. Let's look at some other numbers. These two get swapped. So this is row 0, column 1. This is row 1, column 0. Okay, so those two got reversed. These two also swap, right? These close ones that are easy to see. So what is this? This is row 3, column 2. This is row 2, column 3. And what other ones are like really easy to tell that swap? These two swap, pretty sure. Yeah, because this, well, actually this is the line. Yeah, I think these two, yeah, that should be correct. These two should swap. Yeah. Okay, so if these two swap, then what are these? So this is row 2, column 1, and this is row 1, column 2, and so on. So you can see that like every numbers that are an inverted row and column, like these two and so on, are swapping. And then this, like this number would swap with over here, I believe. Let's see if that's correct. So this is 3, 1, and this is no, that one's not correct. I think it would swap with this one actually. Yeah, it definitely is hard to visualize. Yeah, it would swap. Yeah, it would swap with this one here. Yeah, because this is 3, 1, and this is 1, 3, and so on. So it is hard to visualize it. Maybe it's a little bit easier for a 3x3, because for a 3x3, it's kind of easier to tell what will swap if you flip it, right? Like these two will swap, these two will swap, and these two will swap, right? And those are a little bit easier, but as the square gets bigger, it's a little bit hard to visualize. But essentially, you're going to want to swap all of that. And then, once that's done, and now let's think of these swaps. Like, we want to make sure we swap, but we want to make sure we don't swap twice. So essentially, we need to swap this, 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 and this with these other ones over here, right, on the right side. So we need to swap them with these ones. So like all of these need to get swapped, but we can easily, like once we have this left side, we can easily figure out what the complement is, right? Like we have a row and a column. We'll just say like, okay, whatever's that row column, let's swap it with column row. So that part's pretty straightforward. And then we could do that, but we want to make sure we don't have duplicates. So essentially we need to get these numbers here. And then remember, this diagonal doesn't actually move. You can swap the diagonal, but it'll just swap with itself, right? So it'll be like 0, 0, swapped with 0, 0, because you're just flipping the row and the column. That's why the diagonal doesn't shift. So how do we get these? Like, what's the formula here, you know, if you think about it? Well, you would have a for loop, right? So you'd have a for loop for like all row in rows. So let's just say like for all rows, you know, r equals 0 all the way less than rows, whatever that is. But what about the column? So for the column, we want it to be 0, but what does it need to be less than? Right? Well, let's look. In this first section, we don't have any columns at all, right? We're just trying to get this left side. And then the second one, we have 1 column, and then we have 2. And so this column needs to be less than the current row. It's what you need for the column. So that way, for this first part, we'll have nothing. Then for the second part, we'll have this thing right here, because the current row will be 1, then the current row will be 2, and so on. So that's how you do this swap. And it's, like I said, it's kind of hard to show what the inversion will look like. So maybe we'll just show what the inversion will look like for the 3x3, because that's a little bit easier. So let's actually do that. Let's just show what the inversion will look like for the 3x3, and then we'll figure out what we need to do for the rest of it. And for the 4x4, it is, like I said, it is harder because it's hard to know like what indices exactly swap with each. It's hard to visualize. Like these side ones is easy, but what about these like middle ones or these ones over here are also not super easy. So let's just draw this 3x3 inverted or rotated around that left diagonal. Okay, so we're gonna have this, this. Just have, should be able to, there we go. Okay, so our original 3x3 was this 1, 2, 3 thing here, and now we are gonna show that rotated about, like I said, this diagonal here, right? You're just rotating around this thing here. Okay. And so this 7 should be up here and so on. So we're going to have the 7 up here. This diagonal should stay the same. So it's going to be 1, 5, 9. Now let's look at the rest of it. The 7 and the 3 swap. These two are going to swap. So this is going to be 6. This is going to be 8. And then these two over here are going to swap, the 2 and the 4. So we should have something like this. Okay, and now from here, we're trying to go from here to here. Well, now it's pretty straightforward with the changes, right? You need to rotate it now around this axis here. So you need to do one more rotation around this x-axis. And that's what you need to do. And so let's figure out how to do that. This one's a little bit more straightforward. It's a little easier to see. So essentially what we need to do is we need to take every single number in here that is on the left side and rotate it with the one on the right side. So this like 1 should swap with the 7, 2 should swap with the 8, and so on. So we're going to kind of do the same thing where we have to do this for loop, but now what are our conditions? So once again, for the row, we're going to have the same thing. Row is less than rows. But then what about for the column, right? We don't want to swap twice, because if we just loop through the whole thing and we do swap, then we're essentially going to like go to here and we're going to swap it with 7. And then we're going to go to the 7 and swap it with the 1 again, and we kind of reversed our work. So we need to swap up until the middle. So we can either swap up until this section or up until this section. Either one is fine. And for a 2x2, we would always swap up until this section here. So how do we do that? Well, the row is fine, but the column needs to just be half of the row, like half of the column, sorry. So it needs to be whatever columns is over 2, and then you can either floor divide it or you can round up. Either way is fine. If you floor divide, you would just do this section. Right? So you'd swap 1 to the 7, 2 with the 8, 3 with the 9, then you're done. If you look, that is basically your result. Or you could do this, and then you would swap these, and then this middle one would just swap with itself, which would do nothing. Either one's fine. But we're going to do a floor divide, so we're going to do get this and do a floor divide. So that's our two steps essentially. We do this like rotation around this axis here, and then we do a rotation around this axis here, and then we have our solution. And we are going to do that all like, I'm going to show you how to do like in-place rotations and stuff, and do some JavaScript destructuring and syntax. That's kind of cool. So let's get into the code. Okay, so we're essentially just going to have two for loops, and we are going to have a variable called, let's just call it like side, which is a side length. This is a square, so we don't need like a row and a column. We'll just call that matrix.length. And now we have these two for loops, right? So we're going to say for let row equals 0, row is less than side, side, row plus plus. And then for the column, we're going to have let column equals 0, column is less than side, column plus plus. And this is where we do our rotation around that left diagonal. And so actually, this was a mistake. So remember, our column didn't need to go less than side. Our column needed to be less than the row for this first part, right? Because we only want these elements over here. And then we're just going to be swapping the row and a column. And so for like the first row, there's no elements. For the second row, there's only one, and so on. And so in order to get the elements we need, we would do this for the column index. Now we're going to do a swap in place. And so the way that's going to look is you can actually do an object destructure. So in Python, you could do this. It wouldn't be screen, but let's say you have like var1, var2 equals var2, var1. You can do that in Python, but you can't do that in JavaScript. So the way you could do it in JavaScript is like this. So you could say matrix row column. You do pretty much the same thing, but now you put them in an array. And you say matrix column row. This is, I always screw this up for some reason. Okay, yeah, and then we just swap them. So we just do the opposite now. So we say matrix column row, and so this is called object destructuring essentially. I don't know why I always do that, but I do. Okay. And TypeScript obviously is the same thing. So matrix row column. Okay. So essentially we are destructuring it into two elements, and then these two elements will swap now. So you just say like, that's how you do it. That's the shorthand. You just say like var1, var2 equals var2, var1 if you want to do it in place without a temporary variable. Okay. So that will do that swap around that y-axis, or sorry, about the left diagonal. Now we need one more of these, and this is going to be the swapping the left and the right. And so we just need to swap. We just need to change this parameter. So remember, this needs to be half the column. So we're just going to floor it here. So math.floor side over 2, and then we are no longer swapping like row column. Actually, this is a mistake. So row column, call column. Yeah, this is a mistake. This should be column row. Okay. So this part needs to be matrix row and column, but now we need to swap. Remember, we need to swap the left index with the right index. And so if the left index is 0, what's the right index? Well, it's actually whatever columns is minus the left index. So minus 0, minus 1, right? Because columns is 3 here. So it would be 3 minus 0 minus 1 would be 2. And that's what we need. Okay, so let's do that. Because columns is not, or the side thing is too big. So we need to subtract 1 again. So it's going to be matrix row column, and then it's going to be the row is going to stay the same, but now it's going to be side minus 1 minus column. And then we can copy that in here. This row is the same. This row is the same, and now that should be it. And now, luckily, we can test it. So we can just say, like, let's console log. So this isn't supposed to return anything, but we can console log the matrix. And we can just test some stuff, like, let's just say rotate. And let's have some, rotate. And then we can have some matrix in here. And let's just see if there is an example. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's try that. And that should be rotated, but let's take a look. So 2, 3, 4, 5, 6, 79. Okay, and so you can see that it's 741852963 just like in this picture, right? 741852963. You could try with something bigger, but we have something that looks reasonable, so let's just try to get rid of this. Obviously, I don't really love getting rid of it. Like, I'd probably say, like, better commit it first, but it's okay. Or at least better, like, because you might have more errors and you have to put the stuff back in, but it's okay. So let's just actually run this. But yeah, that's how you do destructuring, and it's a little bit cleaner, looks a little bit cooler, a little bit more impressive, I guess. You could probably clean up the for loop. Yeah. As far as the like runtime and memory, all that, it's going to be pretty much the same for everyone, so it just depends like what you get. But yeah. So let's actually go through the time and space here. Okay. Oh, yeah, it's because we don't have enough space here. All right, there we go. So let's go through time and space. So for the time, we are looping through this entire matrix here twice, right? So this is a side squared or whatever, n squared, where we have n is the length. You can't really do anything. We do technically stop short, so we aren't looping through the whole matrix. We're technically looping through a little bit less than half, because as you can see, like for this example, we're actually only looking at 3 values out of 9. But either way, n over 2, n over 3 is still n. So this part is n squared. Actually, for the row, we are looking at every row, but yeah, as far as the number of elements, we are only looking at like n over 3 elements or whatever, but that's still n squared. Okay. Now for the space, and then yeah, also here we are also doing kind of the same thing. So we're doing this twice, so this is n squared. For the space, we're doing this in place. Like we are creating an array here technically of 2, but it's only 2 variables, right? So you're only creating a size 2 array every time, which is totally fine. This might actually like give you a little bit more space efficiency on LeetCode if you probably don't have this like array destructuring, if you make a temporary variable, I guess. But either way, it's still the same, comes down to the same thing. It's like some small thing. So this space is going to be O of 1 because we are doing it in place. This is O of n squared. And yeah, I think that's going to be it for this one. And yeah, if you did like it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.